Welcome back. I had a little machining job come in last week, and I was initially going to put it on the machining website, but it's cassette related, so I decided to put it here. Customer's working on Sony. Oh gosh, I got to look back on the email and confirm which deck. I think it might be the KA3ES, but I'll confirm that and put it in the description or title or something. So he has 3 of these, and he asked me to turn down the supply capstan to a particular number, and also check the main capstan, pulleys, and balance on these. And so I've got this dialed in, and I was just kind of showing a couple of little things I found with this. Okay, so the capstan shaft is running true. This is 10,000th. The shaft's within about 1/10. And the pulley is really not too bad. It's running pretty concentric. I've seen much worse than this. Okay, so maybe 1,000th or so deviation on the, which is really good. A lot of them, I think anything around 1,000th is probably acceptable after this, many years. Show you a little bit. I'm getting around that unwanted inclusion that you can see right there, right in the path of the tape. And I don't really know what this is. It may have been a hard spot in the casting. These are cast either aluminum or magnesium, zinc. I don't really know. They're pretty lightweight. And there's a lot of, right there's the inclusion there. And that's where you see quite a bit of a bump. You can also see it's right in the middle of where the belt rides. So that's not the reason for the turning. The turning is to take it down to a particular diameter. And I didn't ask. I don't know why. I can only assume that maybe he's trying to reduce the tape tension or put it to a number that he wants. So there's the inclusion right there. A little bit closer. And we'll get that out of there. That's not helping wow and flutter at all. Okay, and there's how it looks on the indicator. And this is turned. This is not as cast. I can easily see the turning, the tool marks. So I don't know, not sure. Okay, I've got it blued up here. I'm just going to take a very, very light skin pass. This took me probably 20 minutes to get set up. I'm using a 6-jaw Pratt Bernard. I can't remember. I think they call it a Just True or something like that. But this is the one that has the 3 screws around the perimeter, not like a 4-jaw would be. But you actually just clamp and then you move the whole chuck into your indicated position. And so there's very little place to clamp on this. A 4-jaw would not have been a good idea because of the amount of clamping force that just happens when you're dialing in a 4-jaw. So this one, like I say, you clamp it to the force that you want and then dial in the entire chuck. It's the only one I know of that works this way. It's a good way to do it, but if you don't do it every day or at least once a month, you kind of lose track of where the screws are taking it. And so it does take a while to get it dialed in there. Okay, so that's the first pass. And it cleaned up well. There was, like I say, it wasn't out very far. Get a good number on it. Instead of blowing those chips away, I should have actually kept them and ignited them, or tried to ignite them and see if it's a magnesium material or if it's actually aluminum. They both turn pretty similar. Now, let me show you here, that inclusion did not come out in that first turning. And it feels pretty good, but you can still kind of see underneath. There it is, I just passed it. Let me come back. Right there on the highlight. Sorry about that. Let me throw a picture up here of it. Okay, so this is after the first turning, and you can see that it's still telegraphing through. So that's an interesting thing. Probably just a hard spot in the casting. Or a hard and soft spot is actually what it feels like or looks like. Okay, so finish this up. Take a second pass here. Like I said, I've got very little clamping force here, and so I'm taking very shallow passes. Now in this last pass, my head and my hands are going to need to be right where the camera wants to show you what I'm doing. So I'm going to win out on that one and just do it off camera. Last pass is finished. That inclusion has been removed completely. And let's just double check, make sure that the pulley is concentric to the shaft. I don't need a zero here, I'm just kind of doing it for you guys so you can see. Okay, so that again is about a 1/10,000th of an inch out of round. TIRs, so that's the actual amount is 50 millionths per side. So TIR is total indicated run out. Let's double check it against the shaft itself, make sure that didn't move. If it did, we're in bad shape. Okay, just right in through here somewhere. Got to realize this is really, really touchy at this level. Okay, didn't move there. All right, I'm happy that this has not moved. So I'm happy with that. I'll touch up the edges and polish it up. And that's how it looks after it's been polished. You can see my grip surface there on the back side. Very little clamping to work with here. Okay, you'll see it a little bit better, but that red plug there is a sacrificial piece, and it has an aluminum post sticking out of it in order to extend out the shaft to fit the balance stand, to be workable on the balance stand. And so now I'm dialing in the pulley that I know is concentric to the shaft, excuse me, and I'll be turning that little aluminum You can see it's not concentric right now. The shaft is concentric. You can kind of see it through the jaws. But the extension isn't concentric, so I have to turn that concentric to the shaft now on the pulley. So I've honed a high-speed steel tool bit to a very high angle and a very high polish, very sharp. This is, like I say, it's a 3D printed plug, and then this aluminum is glued into that plug, and it's, I'll show you, it's not just a piece of aluminum, it's a T-shaft, or it has a flange on the backside, so it's actually pretty rigid. But again, I don't want to move, I don't want it to come loose, and so I'm just taking tiny passes, I'm truing it up. I don't necessarily need it the exact same diameter as the capstan, but it would be nice if it's close. Of course, the closer it is to the size of the capstan, the less walking it will do in a curve on the balance stand. So again, it takes a while to dial these in because it has to be trued up. It's not going to just chuck it and have it be exactly right. So we'll just try to get it there as close as I can and move on. You can also see I have some polyurethane tape on the chuck jaws in order to not damage the nicely polished surface I just got done with. See, I'm just peeling off about the tiniest amount I can. And that tool bit is honed like a razor. All right, I think that's going to be just fine. Sorry for the shake here. I think I bumped the thing the camera was clamped to. Okay, this is just my portable surface plate. You can see it's beat up, but it's the one I use for setting on top of my bench and just using it and then putting it back. The other one's covered up with a carpet, and it's got it's a little bit harder to get to, and it's a little bit harder to photograph, so I just use this one. Should be pretty close. Okay, and there you can see the temporary sacrificial arbor, plug, shaft, whatever I want to call it. Let's open that up just a little bit more. I think I'll face it this way so you can see more of the actual capstan shaft. And this one I don't expect to be in balance. There were no balancing marks on this one to begin with. And also, I took material off of it, and it's apparent that the casting is not uniform, and so I expect this one to be out of balance, and it certainly is. Just make a preliminary mark here and see if it returns to that mark. I've had quite a bit of interest in these few videos I've made about balancing these Capstans, and so I hope the time is well spent doing this on camera. I know it's not an exciting job to watch, but this is what has to be done if you want your capstan balanced. Yeah, so it's very obvious that that's there. Sorry, I'm just trying to confirm that I've got this focused. It's really kind of hard to see it from my position, so bear with me. Like I said, there were no balancing marks on this one initially, and so I guess the Sony foundry cast it perfectly right out of the chute. Either that or maybe they missed it altogether. Yeah, so it's very obvious where the heavy spot is on this. Let's do this a couple of times, kind of confirm that my marks are where they should be before I start taking material away. You'll see on some of the others they'll have 3 or 4 bouncing marks. Sometimes they'll have more than that, and they'll be opposite where they went too far. And you know, that's just something that happens. It's not. This is a pretty lightweight casting material, and so taking a little bit of material off, I think I'm taking a lot, but I'm actually, you know, I'm not removing much weight, and so these take a little longer maybe than the cast steel ones that I see. Okay, I think I'm pretty happy that that mark is within a range that I can deal with. So somewhere in between there, maybe the middle of those two, I think is where I'll start removing material. Right about there. Okay, and there's what that plug looks like. The 3D print was a much faster way to do it, and really out of a lighter material. I guess I could have done it out of nylon or something, but the 3D print is a lightweight and it's fast, and I can be turning the shaft while the printer's printing the plug. So it was an efficient way to do it. Okay, so I'm selecting the size of bit I'm going to use, and get that done, blow everything off, make sure there's no errant chips anywhere because they will affect the balance. It's really important that that's clean every time you drill it. Okay, there's my initial material removal, and you can see it makes almost no difference at all. Yeah, it's still That's okay. You have to get a feel for each one. Everything that gets balanced is slightly different. And to quote Keith Fenner, I'd rather be looking at the extra material than looking for it. I had originally planned on doing this at normal speed, so you could see really how long it takes to do a little job like this. But wow, that would have just extended out this video with, repetitive, boring content for, I don't know, 20, 30 minutes. It just takes a while to get this stuff done. So I went ahead and speeded it up, and just take my word for it that it's a time-consuming process. And there are no shortcuts to this. Just have to go back and forth and back and forth. Many years ago, I read a Henry Ford Jr.'s autobiography, and when it first came out, so I don't know, maybe 40 years ago or so, 30 something. Very interesting. He was talking about setting up his own foundry. Initially, back in the days, he was having the Dodge brothers, I believe this is correct, do all his castings for his engines. And he was having problems with them, with shrinkage and instability of the casting. Now, you think of a cast iron block as being something extremely stable, and it is if it's seasoned correctly. So think of how, you season your cast iron pots or whatever, pans. A block, a casting has to be seasoned also. And it's very unlikely that these capstan castings, or rather the pulley casting, is seasoned. And essentially, as I recall in the book, Henry was talking about his dad setting up his own foundry in order to eliminate a bunch of the problems he was having with the castings he was receiving. And they went ahead, they set up the foundry, and his chief of staff, I suppose, said, we need somebody to run the foundry that's an expert. So as I recall in the book, Henry asked his operations manager there, how long has old, Clyde, I don't know, I don't remember the man's name, but how long has, this guy been working for us? And he was a janitor. He was sweeping floors and things. And he had been there for 20, 25 years. And Henry said, all right. He said, educate him and make him an expert. And this man did exactly that. He became the foundry manager. They discovered that the way to season these castings was to just cast them and then throw them outside for a year and let them go through the 4 seasons. And that stabilized the castings. And then they'd bring them back in and machine them, clean them, and that solved their problem. So even if your job is a janitor, you never know. Be the best damn janitor you can and be loyal to your employer. Okay, this one here, I think I've got it. You can see I can kind of put it in any position and it'll stay in that position. That's basically a balanced assembly right there. I didn't keep track of how long it took, but it was long enough for me to tell a story from memory. And if I'm wrong about any of those facts, please correct me, because that's the way I remember it. Okay, here's the main capstan. And this one did not require turning. He just wanted me to clean it up and balance it, or check the balance. So now I've polished up the belt surface where the belt rides, the crown. And, you know, honestly, this is kind of a ridiculous way to save a couple pennies machining something. You know, if they were worried about the belt sliding off the capstan, the only reason it does that is because of a misalignment between the two pulleys. If they were worried about that, then who knows? I don't know. I just don't think this is the best way to save a few pennies on machining a pulley. Okay, so you can see there I've got it dialed in on the face and the diameter. And I have to make a plug for this one also, and turn a sacrificial shank to have something to ride on. So this is just what I have to do on these to make them work, to make them fit the balancing stand. I thought about a bunch of different ways, but really this is probably the best way to do it. And I thought about briefly maybe building something along the lines of a centerless grinder and incorporating that idea into a shaft. And I think it's possible it could be done, but it would require quite a bit of engineering, and it still requires some modification in order to place the assembly on the balancers. So it's a thought for the future, possibly. Okay, and you can see on this one again, it's heavy opposite their balancing marks. So I expect this one to be much faster to balance than the other one. Right in through there somewhere. Now this one's obviously larger and heavier, and that actually makes it more easy to get it done. Okay, so right there is where I decided to make my attempt. And I'll fast forward through this one just like I did the other one. I'm sure you get the idea of the amount of time that goes into it. And I have 6 of these to do. Alrighty, let's see where we're at. Okay, let's speed this up a little bit. Okay, I think I got my heavy spot marked correctly. Now, the other reason for kind of sneaking up on it is to help know that you're in the right spot, that you're removing material from the right spot. And if you hurry this process up, then you end up putting, 5 or 6 drill marks in it. Now, before I did the other 4, after I got these 2 done, I sent them back, the finished ones I sent back to the customer for his evaluation, make sure that everything was the way he wanted it. And he replied back with a video, and I'll post that here at the very end, showing me the results of the work. And he was happy with it. He was very happy with it. It looked to me, it was a little bit blurry, but it looked to me like the wound flutter was excellent on this. So maybe I can enlarge that in the video. Let me try that. It was a tiny, just physically it was small, maybe like a 600. I don't even think it was 600 by 800. I think it was smaller than that. Maybe I can enlarge it in the video and we can see it better. Okay, that's pretty good. At this point now, it's just a matter of doing like a chamfer on the hole more than doing any more major removal. I might just take one more little drop off. I just want to make sure where I want to take it. Super, super close here. Okay, I think I know where it needs to come off. So after all this, you might be saying to yourselves, gosh, that's a really antiquated and old school way of doing things. And yeah, it is. And it's good enough for use in aviation to this day. So I think it's perfectly adequate for assembly like this. Just make sure I can stop this in about any, clock it anywhere and it will stay put. Yep, I'm calling this balanced. And there's how the plug works on this side. And just move this, and I'll show you that show you how the plug fit on this one. Just like that. So just as I was editing this and getting ready to upload it, he sent me a picture or a short video of the results after he put it back together on that first pair. And I really hope he doesn't mind me adding this to the end of the video here. If he does, let me know and I'll remove it. But here are his results that he's getting. And I'm going to end this one right here because I did not ask his permission to include this video. So I hope you don't mind. So that's it. As always, I thank you for watching and stay tuned for the next one. So long.